Hello, I am going to show you the fault lab since I'm getting lots of emails from people that don't have paper, can't print, can't color it. So you had the fault at the bottom of the lesson, you cut it out and color it as I did. Let me pull this forward so you can see it better. And there are letters on the side. For the normal fault, I ask you to line up spot A with spot B. So you line it up like this, and then hold the fault up. From the side view, you see that the larger portion is lower than the smaller portion of your fault. So you would draw a drawing from the side view. It would look like this. Let me hold it better for you. It would look like this. Then it's going to ask you the questions. Which way did point B move relative to point A? If you turn her around over here, you can see that originally the fault was like this and point B moved how? Then it wants to know what happened to layers X, Y, and Z. Remember, the rock layers are colored green, red, and yellow. So what happened to those rock layers? You can see that here. Are the rock layers still continuous? You need to answer that question. What is likely to happen to the river, the road, the railroad tracks? Well, if you look at this from the top, you can see that something would happen to the river, the road, and the railroad tracks when part of the earth drops. That is the normal fault. You need to explain your answer for that. The reverse fault asks you to locate points C and D on your model. They are on the back here. Move point C next to point D. In this case, the smaller piece has fallen down. You need to draw the cross section. Let me put this back together. The cross section looks like this. You can see the larger part is risen and the smaller part fell. It asks you what happens to rock layers X, Y, and Z again. It asks you if the rock layers are still continuous. And it again asks you what happens to the river, the railroad tracks, and the road. The transform boundary diagram, you locate points F and G. So if I find points F and G, they are on the top of my model. I am going to put the model so the points F and G are next to one another. This is the easiest for me to do. You can see they are still at the same level when F and G are next to one another, but something does happen. There is a gap on the side. You can see on the top, it's going to ask you again what happens to the river, the road, and the railroad tracks. It asks you if the rock layers are still continuous. And again, it asks you about what happens to the rock layers X, Y, and Z. That is all you have to do for this lab. Once again, the normal fault puts rock layers A and B next to one another. The side view looks like this. That's the normal fault. The reverse fault puts C and D next to one another. The side view looks like this. And the transform, you put F and G together. The side view looks like this. If you have continued questions, you can contact me and I will hang out with you and do this with you. But make sure you have your fault model completed before you contact me. Just takes paper. If you don't have the colors, Use X's, use zero, polka dots, however you want to do it, just so you know what you are working with. That's all I have now. I am going to end this recording. Thank you for listening.